Can you tell us what you're doing at Apple? Or?
Well, I can't tell you very much. I work for the communications product development department. It's a long name. And much of what we're doing is proprietary, but I guess I can say that we are involved with connecting Macintoshes with other existing networks out there. For instance, IBM.
Oh, okay. Well, we wouldn't want to pry into that. So, do you have any hobbies?
Well, it seems like most of my hobbies are visually oriented. For instance, painting, woodworking, bonsai, photography. I brought an example of a painting with me here.
Yes, I couldn't help but notice it.
You might enjoy seeing it. Well, it ties into what I'm currently doing, and I call that video synthesis.
Do you have any more examples? Or?
Well, I have examples of video synthesis. The reason I got into this video synthesis, this computing of artworks, was that painting like this really takes a long time to do. It's just a mess with the wet paint and the time you have to invest. Although the effect is nice to have an artifact that you can actually touch and see detail on it, the hand crafting. But I decided to try to use a computer to do something similar.
Were you able to do that?
Take a look at this.
Oh, well, this is very nice.
I combined my hobby of photography to capture that particular object, but it's just a shot of a screen, of a computer screen, and I wrote a program that helps me generate images like this. My art was always fairly mathematical, geometric in nature, and it seemed like a computer was an ideal thing to do.
So we have more examples?
I have plenty of examples here.
Oh, this is beautiful here. I really like this one.
Yeah. Actually, I wish I could take credit for that one. The computer has a free running mode in it where it randomly picks parameters and generates the video all by itself. And that particular one was done in that style.
We have...
here's another one.
I think this is all... Now, I understand you brought some equipment along that you can show us?
Yes, I did.
Well, let's go see it.
Yeah, it's a kinetic art, so really the still photos don't do it justice. I want you to see it in motion, actually, and I'd like to start out with a couple of just examples before I try to explain how this works. Maybe examples similar to those still pictures, but showing the motion that you'll find interesting. Now, the setup I have here is a Macintosh 2 computer with the monitor that comes with it, keyboard, mouse, standard input devices. And I'm also hooked up a board that sits in the Mac 2 that is manufactured by Computer Friends, although several people are making them now, that will generate TV signals. And I thought that would really help this...
Are you saying that this is a video synthesizer? This is your video synthesizer here?
This is it.
It looks a lot like a regular computer.
This is actually more than I need. It's a regular computer.
Except that it has this board in it, which allows you to output regular television signals.
Exactly. The board really helps in this situation where we're in a studio. I've also used it to generate videotapes of these things because I really did want to catch the movement of it. So I'll start the program here, and there's an example. Now what I want to do is switch over to generate a TV signal.
That's very beautiful.
Thank you. And a little bit of clicking. And
now this turns, I guess, that turns the computer into the television.
Right. So now your viewers can hopefully see that image a little bit better.
Now you say this is a video synthesizer. Is that anything like an audio synthesizer or a music synthesizer?
It's really very similar. That's where I got the idea for the name, comparing it to an audio synthesizer. Audio synthesizer, of course, is what people are familiar with musicians using these days. It generates the sounds algorithmically or mathematically. The musicians don't always know it, but there's mathematics and algorithms behind what they're doing, and it's producing pretty sounds. Same thing's happening here. We have mathematics, algorithms behind it, and it produces pretty video.
Well, could you show us some more examples?
Oh, sure can. Let me close this, and this will automatically bring up another window that has...
So is it computing this quickly? That's very fast.
I wish it was. No, it still takes 2 or 3 minutes to compute one of these objects. It's fast enough to be fun, where you can iterate and see the results of your work and decide it's not what you want and then try again. But these images are actually stored on a disk file or disk files. Each one's an individual file, and I can call them up to save time in computing them.
I see. Well, it's good to save time, but could you tell us a little bit about how you put one of these together? I really don't understand the process yet.
Well, let's start with a simple equation, because they're all based on equations or functions of really two variables. And what I'm doing is, this will require a little hand waving, I think, to communicate. But I have a function in 3 space, in 3 dimensions. It's a function of 2 variables. Okay, so we have the x, y plane. We
so this
have
would be x.
Something running through space. Right, x and y.
Okay.
Actually, the 0, 0 point for x, y is right in the middle of the screen in this case, although that's flexibly placed. You can put it anywhere you want to. But I have a function that goes through space. Now, similar to what cartographers do, map makers do, to put 3-dimensional information like the height of mountains on a 2-dimensional surface, a piece of paper, I'm doing the same thing. I'm mapping this 3 space onto the screen by representing the height above the plane, above the XY plane, as a color. So, for instance, in this, perhaps red is 0, and yellow is 64,
what
and
is the
green
equation
is
here?
128. Well, this is a very simple equation, z equals x. So you would expect that the colors would change with x.
This is just
as
increasing out like
right.
this.
So yeah, what you're really looking at is a plane that just goes through the y-axis.
Now, I see that it's red here, and it turns, I guess, green is higher than, or yellow is higher, and then green is higher, blue is higher,
right,
for a larger value of the function. It turns red again here.
Well, I have to reuse the colors. I have 256 colors to work with. It's known as a palette. This computer is actually capable of generating 16 million some colors with the right equipment, but I am restricted to less than that. And I'm showing 256 of those 16 million possible colors at one time on the screen.
Okay, I'm not sure I exactly understand this.
Well, for instance, red is representing both 0 and 256 and 512, multiples of...
So you have 256 colors at a time.
Right.
But you can choose out of 16 million colors?
Right. And, for instance, if I tire of those colors, I can pick, for instance, some blue-green shades. Here, white is representing 0, and black is representing 255, and green somewhere in the middle.
Now, how did you put together the complex figure that we saw?
Well,
or something like that. How do you put together these more complex artworks?
Let me bring up something just slightly more complex. This is the square root of x squared plus y squared, which is basically you're looking down into a cone. And first of all, I want to introduce this concept of animation. Now, instead of actually selecting a whole different set of 256 colors, I can just shift that set of colors so that at one moment white may represent 0, the next instant it represents 1, and shortly thereafter it represents 2.
So that would be like, here is white, and then white is out here representing new numbers.
Exactly.
Okay, I understand now.
So getting that movement is very easily accomplished. I don't have to keep recomputing circles. I'm just changing a little bit of table information.
So you're actually computing a new, or by special purpose computation, a new picture every 60th of a second,
right,
30th of a second here.
Right. It does look different, but there's far less computation. Normally a screen like this would take a minute to fill, and I can change it very quickly.
And evidently you can speed that up.
That's right. I was just playing with the speed controls here.
Okay.
Everybody likes it a little bit different.
I kind of like that.
Okay. Well, just to make things a little more complicated and to get an more interesting figure to look at. This is that same figure you just saw with the arctan of y over x added to it. For those of you familiar with polar coordinates, we're looking at r plus theta, very simply. But it's a really pretty object, I think.
It looks like a pinwheel.
Exactly. Would probably behave like such in the wind, too. Let me change the colors a little bit.